information, but it's also part of discussion. I've done a fair amount of research, and I could probably easily go for an hour if I wanted to on a topic, but I think it would be more interesting that since we've got so many people with so much experience, we're going to make it more collaborative so that, you know, if you've got experience with a particular tool or question, you can raise your hand, perspective interrupt, and discuss it. I imagine that there are quite a few people in the room that have quite a lot more experience with a particular tool more than I do. So it'd be really nice to have you jump in and say, hey, here's something that you didn't cover or misattributed or so on. If you could make it all that and we're all nice. Good? Yeah. So a bit about who I am and where my biases come from. So I've been doing writing applications that deal with databases for 17 years. The past couple I've been mostly working with Python, Ruby, Java. Many of these are web applications. I also build out a Linux that these run on Automate, which is a competitor to things like Puppet and Chef, CFIG. So what I've noticed in recent years, especially now that we're doing a lot more applications that are running on virtualized machines, whether it's some kind of cloud or actually a server we're renting out somewhere, I keep hitting issues with performance and scalability. And so I've been hearing a lot about these non-relational databases. Maybe it's not really explored. So I want to give you some overview of what these concepts are, what some of the interesting tools are required to get you started. So some terminology. We've got our beloved relational databases, which have been in universities for a long time. And the real thing that defines what these relations are is this connection between rigidly defined columns with the
money is an issue.
By contrast, we have things like key-value sets, vertically linear things that are and cache, which just have a single key concept. Single key, single value. And then you've got these documents that are databases, which are ones that I'm going to spend most of my time talking about, which provide a way of mapping a key to either multiple values or some kind of a document that will have rich data.
And if you're more complex and it has really hard to do and say that, hey, I can do this one.
The other part of the document line is that because they don't have a rigidly defined set of columns, each document can have its own column definitions. So just because you can have one record having first name, last name, columns, and then another record having a full name column, just go to
you, and if you're a customer, say that I can do training.
So what's the real exciting thing about these non-relational databases? Well, to me, I see it as being an easier replication and scaling. Scaling and replicating relational databases is kind of pain. There are all sorts of budgets, and especially when it comes to things like schemas, which is the next part. So these non-relational databases, because they don't have a rigid definition of what their tables are, across the tables, incrementally change on a document-by-document basis what their schema is, as opposed to having to stop all the apps, lock all the databases, possibly a very time-consuming, all their table commands and so on. And the other one is better performance. A few of these offer really interesting performance, really good performance, but you have to give up certain things in exchange for them. In some cases, you're not going to get that much better performance. And really, the big parts are why you should actually offer the first two. So why not choose non-relational databases? Well, most of them are not really designed for transactions. They're designed for cloud scale computing, where you have a bunch of these storage nodes cooperating in such a way that they have eventual consistency. This is not something we necessarily want to use for a bank. Transactions
pay money to open source. 30% of the rest of the money they want from the database or decide to talk to the members and basically you can even take the new ones. And 20% is then used to drive the alliance by which means create a website with marketing, promoting, facilitating conferences, promote members in the area. And we currently do like a point and so it's how we use that more than legal paperwork created the legal entity in Switzerland was done some weeks ago because all the final paper on that.
It means they're even more than that. So Joe was mentioning in the previous talk about CouchDB where you can't start and stop it.
So if you are a small company, this process that web here and maybe you are going to speak to that.
In other cases, somebody is very bad at what happens with so most of you very much want to from the get-go start off with cluster configurations that are constructed.
Remember, which case
the other part is many of these are illegal in the certain fashion.
I would think about money.
I'm describing the issue of they're dealing with crazy performance problems. They're struggling with APIs that are changing. They're dealing with data corruption issues. There are also
we have the guy,
lack of documentation, so on and so forth. So this isn't the stability that we learned to accept there's also the other part of this is that to be able to effectively make these tools, you're going to have nothing in there differently. You can't just say, oh, I'm going to drop in a different kind of database and everything will be faster or more scalable. And you're going to have to change everything.
Kind of way you talk about that. That's because I have implemented.
So a couple patterns that you're going to make when writing these applications in this data store is you do not have comments. So you can't say, oh, I want to combine a couple of these things together and give me a composite. To get a similar thing, you probably have to do a bunch of different queries and find retrieving pieces of data together separately and then combining them stuff. Well, that gets expensive because you're doing all these separate. Plus, in the point, you're doing normalization of your data, such as calculations, such as the number of employees in a company, or one case, like you would store the IDs of the employees in a company. That might be more efficient than having to do a query through the employees table to see what employees belong to a certain company, as well as foreign values, such as what's the CEO's name. I guess we have a copy of that stored as part of the company that's displayed. All these ways are trying to reduce the number of queries and find the other approach is track schema versions for a document basis. So for example, you have an employee document, you have a column in there that says this is version 7. And version 7 of the employee document has a certain idea of what the schema is. And that way you can, whenever you touch that document, you can then have your code say, oh, wait, this is an opened up version of the document. Here's how I migrate this particular writer, as opposed to doing this across your database. And being able to do these as-needed migrations lets you perform them on machines that are separate from the ones that are actually doing work. So do them without log your tables, your databases, and so on. Just what we did work about a distinct query. Another part is storing association process. Now this one I was describing as, so sometimes it makes, because a lot of these are operating like key value stores, sometimes it makes sense to be able to say company, its ID number, underscore, employee ID, and then having that map to a separate object as opposed to having to traverse to a data value through one of those. Yes, exactly.
And then this last one, we had like 591 the next line tells you why.
And another big part is shorting data so that you, with some of these, they're actual limited. You shouldn't be putting this much data into this, otherwise you're paying performance penalties, as well as sometimes it just makes sense to have smaller clusters of data storage units that provide a certain portion of the data set, or at least as opposed to having one giant server that's data. So, I'm going to talk about 3 of these non-relational databases: MongoDB, Tyrant, and CouchDB. I'm going to start off with Mongo. All these, by the way, are free or open source projects, which is fantastic. Pretty cool. Mongo was a very neat product in that it's got a fantastic website, great documentation, big API, and a supportive community. I don't say these things often about a project, but I think they're very important because what it meant was within minutes I was able to go from I don't know what MongoDB is, how to use it to that's really valuable. I've written apps, most of which are proof of concepts for clients, and you'll be on Java using this. It's a very general purpose type of database that tries to borrow concepts from data. Doesn't just make this compromise. For example, it adds more features than many of the ones that cost us so, but in many cases, it actually might not be an issue. But this one, by general purpose, means that you can very easily use this as a very close replacement for how to use that was just like these features lend very much to, if you're doing things with a relational database now, you can very rapidly translate those concepts and have it its approaches scalability is either using master and then you have a bunch of root slaves, or adding support in version 1.1 sharding so that you can have multiple machines that operate with each other to serve data and how to switch one story on its own as opposed to that figure it out yourself. It's also resilient. It offers a way of being able to have machines replicate each other so you have multi-master. It also offers many data types and these ideas of integers, strings, index multiple columns. Within documents, it's got a very sophisticated language that it has a common operation that means that you can say, I want you to increment this element's value by 9. As opposed to retrieve the object, increase its value by 1, push it back and then hope that no one else modified it. It also has a map reduce, and they're going to add a shard soon. You build out additional columns of data that are derived. What are the gotchas? Not a whole lot, to be honest. So no transactions across multiple collection types. Collection, so I'll show what a collection type is in a minute. But you can have, yeah, I'll leave it at that. No asset, no MVCC, and it's not the fastest. However, these are fairly minor drawbacks. Any more questions before I switch to the example? Please.
I don't have a lot of database experience, so this may be too naive a question, but the fact that it supports many atomic operations, does that make it at least a little bit better compared to the relational databases in terms of supporting transactions?
So for example, we use these atomic operations to be able to say, increment a value, add a value to a list, remove a value from a list, all without having the risk of retrieving a document, changing it, and saving it again, and potentially having a race condition where that same document is updated no more. So it's trying to solve that problem, but not the traditional trying to make a complex grid that's modifying multiple tables in a relational database. Does that answer your question? So here is a code sample. This is written in Ruby. What you're looking at here is, I'm just going to walk through a little bit of how it works. We got ourselves a key object. We tell it what host we're going to connect to. They individual Mongo server have a database that it has a constant collection. Database has multiple collections. For example, tell the collection, hey, I want you to add index and make it available to make the period quick to be able to search. By just saying, here's my collection object. Saying, push this value into syntax. Here is, this is a Ruby hash. So everything these curly braces is just a normal Ruby hash. One is number, one, and that's no message. And boom, it's in there. And then we can very easily print out I don't want you to find the record where the number is even one, because we're creating an index. And we can also do queries using a find operator where we have inside the collection we have to find message is when it maps to a regular expression B. And so we can turn everything where a regular expression matches the regex that contains I think I see what you're saying. And this whole define syntax is really clever. You can have all sorts of things like select date, ranges, you can have it even execute arbitrarily complex JavaScript on the back end as well.
Is the maximum time for this class?
But that's the power. No. Yeah, so rather than dealing with, so like, with the example with the employees and the companies, if you didn't have any kind of denormalization, you end up saying, give me the company, then you have separate operations list. Give me all employees for their employee ID or company ID matches that company. So you don't have to do that. And more resources, yeah, you do the number of employees you have, and that's like a big normalization. That's getting however, there's definitely denormalization being what it is. It's definitely worth trying to figure out where it's going to actually work. Is it maintaining that denormalized data as possible? So especially if the program goes out there. Wait, am I updating this value here now? So, yes. Is a storage format. It's a big inspiration to try to place things out. Tyrant is a network server which manages the Tokyo cabinet data store. So, for example, we would write a library that accesses Objective Open Disk, and we'd be able to use Tokyo cabinet directly. But in many cases, when you have no network server, you end up having it talk to Tokyo Tyrant server. Generally, is not Tokyo cabinet file underneath. That distinction makes sense. And in fact, this would be like an II sandbox, MongoDB, and MySQL. Anyways, Tokyo Cabinet is an interesting tool. Its approach is specialization. It has a series of backends, different kinds of engines, a key value store, a document oriented store, based engine. This is why I was mentioning. So if you end up choosing you want to become conversant with what are the different kinds of engines and why are they the different ones. They all have slightly different feature sets and of course limitations. And that we're going to be talking mostly about the document. Because it's specialized, it's very fast. But that's where that context, right? You're giving up all sorts of metrics for instance, so many fewer features than MongoDB. It's scalable, it's resilient, so that way master slave, dual master, we can have multiple indexes and multiple columns. Transactions. What you can do is, it's extensible. So I mentioned MongoDB can be extended through JavaScript. This one can be extended through Igal. You can write fairly complex suite. Basically, they're stored procedures that can do all sorts of interesting things on the back end. However, they're awkward enough that you won't. You'll have to decide whether or not you actually want to use it. The other interesting thing it does is it has it's memcache server. Point of memcache server. Memcache iFetch availability. It does very well in comparison to memcache, which is kind of funny because it's also persistent. Cons. You only have one single data type on MongoDB, which has many data types. So this one only stores strings. It's query build simplistic unless you want to write sticky-note scripts, as then you're still going to see your type of application. But again, this one's trying to be minimalistic, strict down, special skills. Here's an example of what this looks like. Here we are saying, give me a database connection, and it's connected to a port. One of the things that's funny about the way that this works, so we saw Mongo has many databases and many collections per database, all pointing within a single server. Tokyo Tyrant can have one on a port. You say, fire base Tokyo Tyrant server and connect it to this one file, and it has one table. Is what it calls it. It's equivalent of a document store. So if you have, so if you want to have the equivalent of multiple collections, it would be other bunch of Tokyo Tyrant servers. In this case, we're looking at a Ruby syntax for inserting a item into a accessing an item with hash. And again, we're assigning the key to this hash, which contains our number and message 11. And we can retrieve it very easily with similar syntax. Saying, give me the record that matches like slow off the database. It's got an interesting, slightly different query language approach where we say, well, we create a query, and then we start adding a whole bunch of conditions to it. And then we have order how many and then you can actually use it.
I'll tell you what, why don't we filter out?
Do you see more people use it as a network server or as like an embedded?
Because they both have really interesting advantages. So being able to network it means you can have multiple clients accessing the single server. You get fairly good performance and multiple things to work with. If you don't use the network server at all, you get access to it directly through the Tokyo cabinet as a DLL. You get insanely fast performance, but obviously only one cabinet at a time. But it's so fast that depending on what you're doing, that's what So, right. So
filter out.
So basically, you have some kind of a queue, and then you're going to build on top of this, and have some process just churning through. Because just talking to the network significantly slows this down, and it might actually just be worth having a single process of accessing this file directly. It's a good question.
Yes. One of the, well, I think it's very promising. One of the negatives that you mentioned, like compare to MongoDB documentation. Like a recent discussion on the mailing list was, this check-in looks pretty interesting. It's anyone speak Japanese, only documented in Japanese. So then it was reduced to Google Translate.
It's a really good point. So, MongoDB it's a large group, there's lots of discussion. There were Tokyo Tyrant cabinet is basically I think his name is. Jack Nixie, which is this Japanese Facebook company, and he has a history of writing very clever things that he kind of gets bored with. And eventually they stop getting them out. So there isn't scaling in the same way. There's not a lot of documentation. You can put together reasonable documentation, but it's not the same kind of vibrant. Well, that's really good because if the research side of it would happen, I think that will be one strength and credibility that project does have.
Really bad things about code that get first actually doesn't say that they exist unless you sync that doesn't global sync. So if you run sync, it actually flushes all the memory.
Yeah.
Right.
We did a test. We compared all the Igal stores, and it did beautifully, but it's synced after each one.
Well, yeah, you can sync after each one. It's everything. So you got to like run it in the background.
Right.
So
Yeah. The other gotcha that I realized is so one of the examples of just how seriously we have to take this very low-level bare metal approach is we create a new table, which is the document around the database, and start throwing things into it. By the time you hit 1 million rows, it's out to lunch. It's gone. Why? Well, you're supposed to know how many objects are in your database and run an optimized program against it to optimize it for a fairly narrow range of objects that you can store that doesn't have, you're wasting space and time. Or if it's too small, you're going to have an absolute heavy fights. As opposed to other ones like Mongo, which is like, you probably want me to increase the bucket size for you. You probably don't want to know what a bucket is, which is much appreciated.
you can start that with different parameters. When you start the parameter, there's a beat.
And then we'll actually
Yeah, because if you leave it as default, like it just sucks.
Yeah.
It's horrible. There's also another parameter because a lot of times the default I think is 64 megs of memory, so you have to allocate more memory to Tyrant as well. Otherwise, it sucks.
Awesome. So I'm very glad to hear that because I couldn't find the instructions for how to deal with that.
It's very unintuitive how you have to start Tyrant. It's actually like, at the very end of the string, you have to put like pound b-num equals this, then this x, size equals this, and all the parameters are just basically, a string concatenated at the end.
Well, but that's good news in the sense that what I was having to do was whenever the bucket size issue would become a problem, I would have to kill all of these databases. You run the optimization, you start them and make sure that all the things are using them have a concept of how do I deal with this. Which you should have anyways, but yeah.
I'm running benchmarks right now at 8 million, 10 million, 50 million rows. No issue.
Yeah, but obviously, for example, I'm mentioning those notes. If you tell it, hey, I do have a whole heavy ordinance, then it's fine. But I'm glad you mentioned it. Thank you.
Yeah.
What's that? Any other questions on this?
There's a lot of expressions as well.
Next one's CouchDB. This one's a really promising and interesting project. I'm really excited reading about it. There's a huge amount of buzz. Some of the things that it does, which are really interesting, is that it's ridiculously scalable. You can have tons and tons and tons of masters all replicating to each other. And this is possible thanks to doing version of objects so that the server can tell, I've got these versions that have these legs. It has MPCC, it has ACID, that's a web server, which means that you can do things like, I'm going to add which is actually the HTML page, and I don't know if that's read it out in the web browser. The web browser happens to process HTML, it has a JavaScript, and it uses the JavaScript to connect back to the database. And it music, which is really kind of neat about it. You have some fairly sophisticated queries because you're basically writing arbitrarily complex JavaScript. It has a nice macro use. But all these features come with it. It's 40 sometimes. It's written in Erlang, which is normally a very fast language. I don't know what happened, but it performs something like 40 times slower than those games I type that in. And I've had folks on the account to verify that there's not spurious results. The other part is, so this, I would be shocked if this was Erlang small, but I think it's going to happen because CouchDB has so much power in these features. At some point, we're going to either have enough manpower or money or something to be able to later figure out why those particular things are running so slowly that we implement it. But, so I wouldn't give up on this just because I'm sure although that's going to be a stumbling block, I can't sit until we deal with file that piece. The other interesting thing is that you do not have a way of being able to throw arbitrary queries at. You have to read the lines, which I'll show you in a minute. It's also a lot. I found it quite a bit harder to use. There's cited documentation that helps with terrible. I was trying to do, you saw how complex some of the queries are than the other ones. They're not complex. I couldn't figure out how to do them for hours. Which is really a bad sign in terms of your documentation needs to be assigned or figure this stuff out. And so I was really disappointed. I hope that as part of the vibrant community, they come together and start writing some better documentation, as well as find documentation that's on their site that's actually open or put it out as a description. It's a really neat project.
If you don't mind, I'm going to chime in on the slow stuff. So the company I work for is Cloud, and we're doing clustered CouchDB in the cloud. So slowness stuff. I think the difference there between like CouchDB and Tokyo Tyrant is Tokyo is definitely more in memory than CouchDB. So like a lot of what's stored in memory in Couch is like metadata and stuff with the B tree, and whereas with Tokyo, all data is like stored in memory until you do right? So I think that's the big difference, right? Because all this stuff is being written to the disk with Couch, rather than in Tokyo. If you cut it off, it's gone, right?
Yes.
So I think that's the big difference in performance. And one thing I will say regarding the views is they're incremental. So as you add more stuff or update documents, they'll get incrementally updated. So querying those views happens very quickly if you're hitting those views often because they're getting updated all the time. So yeah, as far as docs, the API docs are okay. Writing views docs are not so good.
And that was also, there's definitely also a point where this doesn't make sense. Okay, I think I see how this works. Now these other documents started or documentation starts to make sense. With the other tools, for the most part, there wasn't, bam, you run into build that user.
The trick with Couch also is it's community REST. So if you know how to use curl and do a post with JSON, you pretty much get Couch for the most part. There's obviously changes to that. I guess the other important thing is we're talking about multi-master replication and stuff. Replication is super simple with Couch. Basically, you give it a URL and you say replicate, and it replicates, and to where the database is. And that's one of the really cool things about Couch is how easy replication is. So, and you can configure them so they'll replicate like persistently. So, if you restart the server, it'll figure out where it left off and replicate all the docs, just like you would with MySQL or something like that.
You also mentioned the ability to get CouchDB. This approach you're talking about is
Sorry.
your use of varnish.
Oh yeah, you can, so rather than using like even MinCacheD or something like that, you can cache everything using varnish or squid or whatever normal HTTP caching mechanism you already use. So since it's all HTTP and REST, you can even set things up. I've heard someone about using the varnish purge to get rid of old docs and varnish. So it's almost like authoritative caching essentially. So yeah, I mean, there's lots of cool things simply because it's HTTP and REST to do with Couch. So yeah, if you guys want to talk about Couch, there's a talk tomorrow by one of the founders of the company I work for, and you can talk to me. So.
And I think also Jay Chris is going to talk tomorrow as well.
Is he?
Yeah, he's one of the Couch.
Go.
So, code. One other thing. So, part of also the performance can also be, for example, you mentioned the REST API wasn't talking to HTTP. We're pretty sure that that is adding some overhead. The other one is a very efficient binary protocol. So, you know, there's been some discussion here about would you be interested in that if I can tell you Couch.
There is hovercraft, which is an Erlang, basically talk directly to the CouchDB binary files, I think, through Erlang. So that obviously has to be an Erlang, what you're using for, but I think that talks directly to the file, rather than uses the Couch APIs, internal APIs to deal with that, rather than using REST. But yeah, obviously it has to be on the same machine, so it's more like an embedded database at that point.
So slap a network socket on it. So anyways, here's what it looks like. We run Southwest 8. So this is we have a server running on this port. It has many tables effectively that is stored that you can compartmentalize and create so in this case, this is really syntax for saying, convert everything in those parentheses into this is a hash or a dictionary if you're a Python user and just stashes into the database. Very simple get method to retrieve it. This part's real easy. The next one, though, is what a query looks like. So, what we wanted, so the goal is to be able to say, give me an object with number and one. The other ones we were able to say, final one, number is one. That's it. This is what we have to have here. So, we start out by saying, hey, you're going to have the graph which is called queries in this case. I want to get rid of that, so we have updated that. We're then going to create this new with this view called by number to generate the contents of the by numbers. But here, what we're doing is adding a column to every single object that says what is the number for that object and how we'll create it. What it's doing is it's inspecting each document and it's kind of and getting that yes. So this is really good. And then we have this quote here. And this is all JavaScript inside. Once that's in place, then we're able to execute these methods where we get back a result. We then say, out of that result, give me back the rows. Out of the rows, return the value back. So that's what I meant by it's harder. The other ones, they went through the extra steps of providing wrappers to be able to do some of these things. Whereas here, this is left for
I think it seems to be a different approach because in the other key value stores, it seems as though you have to denormalize and save off the measure into the actual date, where this is allowing you to essentially look at it the other way around. So, I mean, it's going to have to be different. I mean, both of them have the same level of complexity. It's just a matter of whether it's on the slide side or on my side.
Well, I imagine we'll also see the proliferation of add-on libraries that do some unique things like this. If it's annoying enough, you could have something for you.
I think the stance on Couch is to make the ORM as thin as possible. And like for a lot of stuff that I do, like on a daily basis, I use just the simple REST client to do most of the stuff that I do. So I'm just doing gets and puts and hitting views and stuff like that. And I've thought about all the views ahead of time, and I get back. I've written the views in such a way that I get back what I want, and it's easy to parse out the values I want from the return on the value of the view. So like, I think a lot of the ideas that for Couch specifically is make that ORM thin and put all the processing lines and sort of things.
Yeah, that would be an example where in general we're going to speak about patterns. If you're going to adopt this, go full in with that kind of approach.
And each of these kind of have their own way of doing it. So when you're investigating these, you kind of have to find one that matches your data and matches kind of the way you think about your data or that sort of thing. So you can kind of
examples being, whether, for example, everybody concerned about what happens if I use data, Couch would be a better singer handling of this pattern versus more worried about performance, which means decisions.
Right. I mean, if you're concerned about your data, you're not going to put it in CouchDB, but you'll put it in CouchDB. So, and you have to. There's a trade-off, right? There's always trade-offs. So.
I forgot to.
The other things you mentioned were ORMs. And so, for most of these, folks are busy writing ORMs. So, for example, there's a nice ORM. I bet Jake wants to go off what it is, but an ORM that provides a Ruby on Rails driver, so you can use CouchDB as your storage engine, and otherwise things that you in normal Ruby app record models. Which takes away, takes some of the because, for example, Ruby on Rails models are more instead of interesting to build out, instead of trans text from those to
which is the actual abstract.
In fact, we're trying to do.
We've got the sample, which is the first sample. We've got the first and last.
questions on this?
And we've got comments.
So, real quick, here's some interesting benchmarks. I mean that they're running their single machine, it's running a type loop, and it's inserting a document that has a message and an incremented number. The tree, once you go through and queries that say, find backward, looking for a match. So I throw in things like Memcache and OpenSQL So the first column is inserting a single record. How many records you can insert? This is how many people that read. The second one, the third one is how many queries. For example, Memcache has no way of reading it. You can only say retrieve one by ID. So you can see that, this is where I was talking about CouchDB performance. As you can see, Tokyo varies.
So now I can ask.
And
What sort of, sorry?
Next time,
What's the time span?
this is per second.
What sort of, storage were you using on Tokyo?
Oh, this is using the table.
Was it the hash or was it?
That's why I came up with If you use the key, you see which we get over 1 million per second. Wow. I'm not going to want to write C. But anyways, trade-offs again. You can see Mongo does pretty darn well. And one of the things that I thought was really funny was Postgres and MySQL here. You can see Postgres' inserts were kind of slow, but it's got awesome fast retrieves and queries. MySQL and MySam have ridiculously fast inserts. Switching to MongoDB, it drops to like class. But you can see that Postgres and MySQL, they're doing fairly well. And that's why I was mentioning earlier on about performance not necessarily being show which ones closer matches to what I want. In a nutshell, MongoDB is less nice where, you know, the drawbacks of things like schema annotations, the gas on relational databases, but sometimes make up for those things that other people not. But you can see this graph, there's a URL, really simple, very first slide you can write down. It's also the good of that was the scale sample.
And then scroll all the way to the bottom.
So conclusions, MongoDB and Tyrant are probably really useful together. In some cases, it seems like there's a definite fitness for it. But that one's a lot of me right. There's a lot of communities that are moving to use these non-relational databases that are operating larger sets of servers. This is in particular the concept. This is actually being used in its work data.
And then there's going to be,
we're going to see a lot more. A lot of lines are taking things that we're going to third of the year. But it's either the APIs are going to change them. There's going to get some data. The last thing I want to close out with, even though these non-relational databases are really interesting, your knowledge of what you know about relational databases is not going to be pronounced. They're still really useful, they're still very valuable, they're reliable, lots of people understand how they work. So, you know, don't write them off. And I think what's interesting is that with proper caching and minimalization, which are things we also talked about with other tools, relational databases will perform really well. And there's also an interesting rework effort. There's a tool for file database like authentication this year, as well as the history. So this isn't a, you know, one of these really stuff you want. There's definitely a pick the right tool for the job for. I let it sink right to us. As it was necessary.
Is that ever by default?
Yeah. It has some algorithm that sinks.
Okay.
No, actually, internally, it's when it fills up its memory and seals over, and it's something that's really not with those.
So, if
If you look at the code, there's only an msync call when you physically call the sync command, so you're relying on it.
So if you never called sync, all those numbers are. That's a good homework assignment.
That was one of those things that I really wanted to say in my letters on the dogs.
Yeah,
Wow. That's why it's so fast.
yeah, did you feel with the tables, the warnings about table type work?
If you don't have indexes,
But yeah, it's amazing if you look at the code and you look actually for sync commands.
Yeah.
They're only called in one place. And it's like all things like if you start a transaction, end a transaction. Even transactions are global, so it's only you can only run like one transaction at a time anyway. So nobody ever uses it from what I've seen.
So, yeah, so how do people come up with it? Do they have like a on job that
No. Well, I actually asked that. I think but he actually responded that you should use replication. Wow. Which I responded that was really in all cases. So anyway,
thank you very much for pointing that out.
the sync command is something that is kind of made. So, but it is doing something behind the scenes to push data out depending on the settings.
Yeah.
And when you exceed the amount of memory that it actually has to push data out, I haven't tracked that down yet. So.
Yeah, I saw him writing data. It didn't occur to me that I should like hard about that.
Yeah, and physically close down the server, that will sync in. What's kind of amazing is if you kill the process, means it's going to have that file, the data actually stays in memory, shared memory. So you start back up again, all the data's there. But if you pull power from your server, it's already used it.
That's
I actually learned about that in MySQL before it's long, if anyone's interested. There's several articles about it.
Grab MySQL.
So is this just the URL I was talking about? Presentation.
There are copy and paste.
Really great.
All you have to do is just say dash dash dash. And it knows how to understand MySQL.
For putting in these points about these conditions and stuff that these tools.
Not as much as
You got the overview points from those that are going to be using Any other questions before we adjourn? So, I did not evaluate Cassandra because it's a very interesting tool. It's sufficiently different that I needed to be able to, I didn't quite wrap my head around its approach to things. Whereas some other issues that forget what, that basically put it out and run for 6 projects. One of our customers research, however, this is all I did. You're like, hey, I want to consider that all of the data and subscribing it. I'm happy to as someone that's actually worked with Cassandra, maybe mention a couple of things. Maybe I just walked out. How about this? Like, given the kinds of pros and cons that
plain old web surfing.
Yeah.
Well, it is key value, but the value structure.
Yeah, the good part was that they used such a good paradigm, and that it was much harder for me to get
Whatever I'm giving you, use that.
figuring out.
So I can do it for, large device, having your data,
So there's
close matches tomorrow,
that whole concept of a pipeline, which
giving
creating
time for your
And so by scaling, if I recall correctly, that for Cassandra's case means that it's smart enough that you can just drop in nodes and building out their
we like to do
bring each other to
I have some things on our site that I think I might, but I don't know.
So yeah, that's a big difference because all these are mostly single machine.
You're responsible for figuring out how to do it.
Yeah, exactly. And whereas Cassandra's like, it's a dynamo system, so it's its idea of the world is to have multiple machines, not just
I'd definitely like to know more about it.
Sure, identify this table.
The other part I think that quickly off is all the warnings that people said that the way that Cassandra is able to namely that it's very abusive of the way it deals with
And by the way, there are lots of
it performs very badly on virtualized networks. I don't know what bad is in this case, but
it's better than EC2. I don't think it's really good establish why. I know it runs, reportedly runs much better on. I mean, I don't know